am Sujit. Welcome to Physics 2020. So in this section we are going to discuss the 10 numericals of projectile motion, that is projectile motion at a certain height, okay, at a certain height. So in the previous class, in the previous section we have discussed the theory of, that is the projectile motion at a height. When an object is projected horizontally from a certain height, what is the time of flight, what is the horizontal range, and what is the velocity of the projectile when it hits the ground. So these are the expressions we have derived. Also some two cases we have discussed. What are they? That is when a projectile is projected at a certain angle above the horizontal, when a projectile is projected at a certain angle below the horizontal. Okay, so these are the things we have discussed in the previous class. So in this section we are going to discuss the 10 numericals of that is projectile motion. Okay, let's see. So first question. Can you read this question? Okay. A bomber is flying horizontally with a constant speed of 150 meter per second at a height of 78.4 meter. The pilot has to drop a bomb at the enemy target. At what horizontal distance from the target should he release the bomb? Okay, understand the question. So one bomber, that is, let us first visualize the situation, then we can clearly understand. Okay. So listen here. So one bomber is in the plane. Okay. So this is a our flight. Okay, flight. A bomber is in this plane, and so this is the ground level. Ground. Okay, ground. Okay, so a bomber is flying horizontally with a constant speed of 150 meter per second. So with the velocity of this plane is, that is 150 meter per second. At a height from the ground, that is 78.4 meter. 78.4 meter. So the pilot has to drop a bomb at the enemy target. Okay, enemy target. So one bomb has to be dropped from here. Okay, dropped from here, and it should reach the enemy target. So the enemy target is here in the ground. So this is the enemy target. Okay, enemy target. So at what horizontal distance from the target should he release the bomb? So otherwise we can, so the bomb is here. Okay, the bomb is here. So at what horizontal distance? So this is the horizontal distance. Okay, at what horizontal distance from the target? This is the target. Should he release the bomb? So we are considering that at a horizontal distance of capital R. Okay, capital R, he must release the bomb. Okay, he must release the bomb. Then only it will clearly hit the target. Okay, hit the target. So when a bomb is dropped from the flight, which is moving with 150 meter per second, what is the initial horizontal velocity of the bomb? That is 150 meter per second. 150 meter per second. that is initial velocity in the horizontal direction. That is, we can write that is ux is equal to 150 meter per second. Very, very important. An object is dropped from a moving plane. Okay, moving plane. So the plane is moving with a certain velocity. Suppose if you are dropping an object, okay, dropping an object from the moving plane, it has the same velocity as that of the plane. Okay, horizontally, the object will move horizontally, and it has the same initial velocity as that of the plane. That is very, very important. Okay, so the plane is moving with 150 meter per second. So when the bomb is dropped from this plane, okay, plane, so it has the initial velocity as that of the plane. So this is our bomb. Okay, bomb. And it makes a parabolic path. Okay, parabolic path, and it reaches the, or it hit the target. Okay, target. So suppose we are considering at a distance of capital R, horizontal distance is capital R, the pilot must drop the bomb, then only it will clearly hit the target. Okay, hit the target. So what is the initial velocity? That is the velocity of the bomb in the horizontal direction, that is 150 meter per second. So our bomb is our projectile. Okay, projectile. So y, that is the initial velocity in the vertical direction. So that is equal to 0. Okay, 0. So this is a point A, and this is the point B. Okay, and this is the point I am taking, this is O. Okay, so from A to B, so I am considering that is the vertical motion. So we have discussed that is the projectile motion. So it is the combined motion of, that is horizontal motion and vertical motion. So we have to separately consider that is the horizontal motion and vertical motion. So vertical motion I am considering. Vertical motion. Okay. So I am using the kinematic equation S is equal to, okay, S is equal to ut plus half at square. So I am rewriting this equation, that is Sy is equal to uyt plus half ay t square. So what is Sy? What is Sy? Sy is equal to minus 78.4. So the displacement, S is a displacement. It is measured from this direction, it is positive. So when we consider the vertical motion, we are measuring from this point to this point. So negative direction. So minus 78.4. Okay, uy. So that is the initial velocity in the vertical direction is equal to 0. Acceleration ay in the vertical direction, that is minus 9.8. Okay, 9.8. Okay, so come on, substitute the values. Substitute the values. So Sy, that is minus 78.4 is equal to, so this term becomes 0, that is uit becomes 0, that's equal to half into, okay, half into minus 9.8 into t square we have to find. Okay, so this minus cancel. Okay, so 2 4 times 4.9 9 2s are 18. Okay, 9 2s are 18. So t square, from this t square is equal to 78.4 divided by 4.9, that's equal to 784 divided by 49. So 7 7s are 49. So 1 time 7, 1 time 7, so 1 is balanced, so 14, so 2 times. Okay, 2 times. So that's equal to 112 divided by 7. So again cancelling with the 7. So 1 times 7, 4 is balanced. Okay, 4. So 42. So 6 7s are 42. Okay, 6 sevens are 42. So t square is equal to 16. Okay, t square is equal to 16. Therefore t is equal to, so that is t, that is capital T we can write, that is the time of flight. T is equal to plus or minus 4. Okay, plus or minus 4, but time cannot be negative. Okay, time cannot be negative, so t is equal to what? T is equal to 4 seconds. T is equal to 4 seconds. Okay. So next we have to find this horizontal distance, that is the bomb must be dropped at a distance of capital R from the flight, then only it can clearly hit the target. Okay, target. So that capital R we have to find. So capital R. So I am from this O to B. Okay. So I am considering the motion. O to B. That is horizontal motion I am considering. Horizontal motion of the bomb. Okay, horizontal motion. Okay, horizontal motion. So I am writing the equation S is equal to ut plus half at square. Okay. So I am rewriting the equation, that is S x equal to uxt plus half ax t square. Okay, t square. So what is Sx? So from this equation, what is Sx? Sx equal to capital R. Okay, Ss equal to capital R. Ux, that is the velocity in the x direction. Okay, x direction. So the horizontal velocity throughout the motion, the horizontal velocity is constant. Okay, horizontal velocity is constant. So ux equal to, what is ux? Ux equal to, so this 150 meter per second. 150 meter per second. Okay, what is ax? That is acceleration in the horizontal directions. So the horizontal velocity is constant. So the acceleration is equal to acceleration in the horizontal direction. Ax equal to 0. Substitute the values. So Sx, that is capital R, is equal to Ux, that is 150. Okay, 150. So T is nothing but it is time of flight. Okay, time of flight. So T is equal to, we have found, that is 4 seconds. 4 seconds. Okay, so 150 into 4. Okay, 150 into 4 plus half into Ax. So this term becomes 0. Okay, this term becomes 0. So 0. So that is R is equal to 150 into 4. That is 600 meter. That is the answer. So the bomber should drop the bomb at a distance of 600 meter from the target. Then only it can clearly hit the target. It can clearly hit the target. Clear? So second question. A body is thrown horizontally from the top of a tower and strikes the ground after 3 seconds at an angle of 45 degrees with the horizontal. Find the height of the tower and the speed with which the body was projected. So take g is equal to 10 meter per second square. Okay. So this is a question. So let us start. Come on. From the top of a tower. Okay, top of a tower. So this is our tower. Okay. This is our ground level. Okay. So this is the tower. So of height h. So height is not given. So capital H. Okay, capital H. Body is thrown horizontally. So with the velocity, velocity is not given, that is u is the velocity. Okay, u is the velocity. So the ground after 3 seconds, okay, it strikes the ground. So the path of the projectile is like this. Okay, path of the projectile is like this, and it reaches the ground in 3 seconds. That is the time of flight is equal to given, that is 3 seconds. Okay, time of flight, and it makes an angle of 45 degree with the horizontal. Okay, horizontal. So when it reaches the ground, so it has two velocity, that is one and this one. So that is the projectile undergoes two types of velocity, that is horizontal velocity and vertical velocity. And when it reaches the ground, so it makes an angle that is 45 degree. Okay, 45 degree with the horizontal. Find the height of the tower. So we have to find this height of the tower and the speed with which the body was projected. Okay, so what is the velocity of the object, initial velocity of the object at which the body was projected, we have to find. Clear? Okay. So first one, so we have to find the time of flight. So this point I am taking, that is A, and this point, that is B. Okay, B. So this point I am taking, that is O. Okay, so from again, that is I am taking, that is A to B. Okay, A to B, I am considering the vertical motion. Vertical motion. Vertical motion. So I am using the kinematic equation S is equal to, okay, S is equal to ut plus half at square. Okay, I am rewriting this equation because I am considering the vertical motion. So Sy is equal to uyt plus half ayt square. Okay, ayt square. So come on, Sy is equal to, what is Sy? Sy is equal to our height, that is the vertical distance traveled. Okay, vertical displacement. Okay, vertical displacement. So that is height. So when it is measured in the downward direction, that is minus h. Okay, minus h. Uy, that is equal to the vertical, initial vertical velocity, that is equal to 0. Okay, 0. Acceleration, that is ay. Ay is equal to minus 10. Okay, minus 10. Acceleration is always negative because it is always acting in the downward direction. Okay, downward direction. So substitute the values, that is, come on, minus h is equal to, minus h equal to uyt, uy that is 0. So this term becomes 0, is equal to half, what is ay, that is minus 10 into t square, that is time of flight, that is it is given, that is 9. Okay, 9. So this minus minus cancel. So 2 5 times. Okay, so h is equal to 9 5s are, that is 45 meter. That is the height of the tower. Okay, that is the height of the tower. So the second thing we have to find, that is find the height of the tower and the speed with which the body was projected. Okay, body was projected, we have to find. So this is ux, right, that is ux, the initial velocity in the horizontal direction. So when the object hits the target, okay, hits the ground, okay, hits the ground, it has two velocity. One is horizontal velocity and another one is vertical velocity. So horizontal, final horizontal velocity, that is vx, and final vertical velocity, that is vy, right? So what is vx? Vx equal to, that is ux, am I right? So that is throughout the motion, that is the horizontal velocity is constant. Okay, So Vx equal to Ux. What is Vy? Vy is equal to, we have to find. So Vy is equal to, using the equation, that is V is equal to U plus At. Okay, so Vy is equal to Uy plus Ay into T. Okay, so Uy, that is 0, plus Ay, that is minus 10 into, what is T? That is time of flight, that is 3. Okay, so that's equal to minus 30. So minus sign means that is the velocity in the downward direction. It represents the velocity in the downward direction. So Vy is equal to minus 30. So we have only magnitude, that is Vy is equal to 30. Okay, Vy is equal to 30. Vy is equal to 30. So now we know that is Vy, that is Vx equal to, that is Ux, Vy is equal to 30. Okay, 30. So when you complete this parallelogram, okay, parallelogram. So tan 45 is equal to, from the diagram, that is it makes an angle 45. In the question it is given, it makes an angle 45. So tan 45, okay, tan 45 is equal to, tan 45 is equal to, that is opposite side, okay, opposite side, that is Vy, by adjacent side, that is Vx. Okay, tan 45, that is 1, is equal to Vy. So we have already found, that is 30. Okay, 30 divided by, okay, 30 divided by, that is Vx. So Vx we have to find. So what is Vx? That is Ux. Okay, Ux. So therefore Ux equal to 30. Ux equal to 30. So that is Ux. That is second one. That is the time. Find the height of the tower. So height of the tower we have found, that is h is equal to 45 meter. So and the speed with which the body was projected. So it was projected with, that is 30 meter per second. Okay, 30 meter per second. Clear? So third question, a projectile is fired horizontally with a velocity of 98 meter per second from the top of a hill of 490 meter high. Find the time taken to reach the ground. 2. The distance of the target from the hill. 3. The velocity with which the projectile hits the ground. So read the question. A projectile is fired horizontally with a velocity of 98 meter per second from the top of a hill of 490 meter high. Find the time taken to reach the ground, the distance of the target from the hill, the velocity with which the projectile hits the target. Come on, let us start. So this is our hill. This is our hill, okay? Of 490 meter height, okay? So this is the ground level. This is the ground level. So 490 meter. Okay, a projectile is fired from here. So this is our projectile, okay, projectile with a velocity of 98 meter per second, that is Ux equal to 98 meter per second. So the projectile Okay. Right. Find the time taken to reach the ground. Time taken to reach the ground means time of flight we have to find. Okay, time of flight. Time of flight. One we have to find, that is time of flight. 2. The distance of the target, that is the distance of the target from the hill, that is horizontal range. 3. That is the velocity with which the projectile hits the ground, that is the final velocity of the projectile. So these are the 3 things we have to find. Okay, so this is the horizontal range. Okay, horizontal range. Come on, that is this point I am taking A and this point I am taking B. Okay, so this is the point O. Okay, O. So I am considering the vertical motion from A to B. Vertical motion I am considering. So as we know that, so the projectile motion is the combined motion of horizontal motion and vertical motion. Okay, vertical motion. So I am considering only the vertical motion from A to B. Okay, A to B. A to B. Okay. So what is the So I am using the kinematic equation S is equal to ut plus half at square. So I am rewriting this equation, that is Sy is equal to uyt plus half ay t square. Okay, t square. T square. So what is Sy? Sy is equal to the vertical distance traveled, that is 490 meters. So minus, so the displacement which is measured in the downward direction, that is 490 meters. Uy, initial vertical velocity, that is 0. Acceleration Ay is equal to minus 9.8. Okay, minus 9.8. Come on, substitute the values. So minus 490 is equal to uy into t, that time becomes 0 because uy is equal to 0, that is half ay, that is minus 9.8 into t square. Okay, t square. So this minus cancel. So 2, 4 times, 9 times. So 9 2s are 80. Okay. So 4.9 t square is equal to 490. So t square is equal to 490 divided by 4.9. So that's equal to 4900 divided by 49. So this cancel, that is 100. Okay, that is t square is equal to 100. So therefore t is equal to plus or minus 10. Okay, plus or minus 10. So time cannot be negative. So therefore t is equal to 10 seconds. T is equal to 10 seconds. Clear? So next time, horizontal range we have to find. Okay, horizontal range. Horizontal range. So I am considering the motion of the projectile, that is horizontal motion, O to B. Okay, horizontal motion. Horizontal motion, that is from O to B. O to B. So I am considering again using the equation S is equal to ut plus half at square. I am rewriting the equation Sx equal to uxt plus half ax t square. Okay, ax t square. What is Sx? That is capital R is equal to ux. Ux, that is the velocity in the horizontal direction. That is the horizontal velocity is constant throughout the motion. That is ux equal to 98. Okay, 98 into what is time of flight? T, that is 10 plus half ax, acceleration in the horizontal direction, that is 0. So this term becomes 0. Okay, so 98 into 10. So R is equal to 980 meter. That is the horizontal range. Okay, horizontal range. So third, final velocity. So the object has the final velocity v. So this is the final velocity. So when it hits the ground, it has two components of velocity. That is the horizontal component of velocity, that is vx, and vertical component of velocity, that is vy. Okay, vy. So vx equal to what? That is 98 meter per second, because the constant horizontal velocity is constant. Okay, so vy is equal to the vertical velocity is continuously changing. Okay, due to acceleration due to gravity. So vy is equal to we can write that is uy plus ay into t. Okay, so uy, that is 0, plus what is ay? That is minus 9.8 into t, that is 10. So that's equal to minus 980. Okay, sorry, minus 98. Okay, minus 98. So the minus sign represents that is the velocity is acting in the downward direction. Okay, downward direction. So that's why this negative. Okay, the vertical component vy is acting in the downward direction, negative y-axis. Okay, negative direction. So that's why this minus. So we have the only magnitude. So vy is equal to 98. So vx equal to 98 meter per second, vy is equal to 98 meter per second. So how we can write the velocity vector? V vector is equal to, we can write, that is 98 I cap minus 98 j cap. Okay, so the magnitude into unit vector. So unit vector in the along x-axis, so I cap. So the unit vector along the negative y-axis, that is minus j cap. So therefore we are writing that is v vector is equal to 98 I cap minus 98 j cap. Okay. So what is the magnitude of the velocity? Okay, magnitude of the velocity. So magnitude of the velocity we have to find. So this is velocity vector. Okay, velocity vector. Magnitude of the velocity, that is modulus of v vector. Am I right? Modulus of v vector is equal to square root of 98 square plus 98 square. Okay? So that's equal to root of 2 into 98 square. So that's equal to 98 root 2 meter per second. So this is the magnitude of the velocity or speed. Okay, speed of the object when it hits the ground. 98 root 2 meter per second. Clear? So fourth question. A body is projected horizontally from the top of a cliff with a velocity of 9.8 meter per second. What time elapses before horizontal and vertical velocity becomes equal? Body is projected. So let us visualize the situation first. Okay, a body is projected Okay, projected horizontally from the top of a cliff with a velocity of 9.8 meter per second. So this is the ground level. So this is ux. Okay, ux. Okay. So throughout the horizontal motion, that is the horizontal velocity is constant. Okay, horizontal velocity is constant throughout the motion. So the vertical velocity continuous changes. Okay, vertical velocity. So throughout this projectile motion, so at each and every point, that is the horizontal velocity, that is ux. Okay, 9.8 meter per second. It is not changing. Okay, not changing. So what about the vertical velocity? Vertical velocity continuously changes. So after time t, okay. So let us consider that if we have to, what time elapses before horizontal and vertical velocities becomes equal. So after time t, the velocity, horizontal velocity and vertical velocity becomes equal. So after time t, so Vx equal to Vy. So the horizontal velocity is equal to vertical velocity. So what is vertical velocity after time t? So Vy is equal to Uy plus Ay into t. Okay. So what is Uy? That is the initial velocity in the vertical direction, that is equal to 0. So Vy is equal to, we will get, that is Ay, that is minus 9.8 into t. Okay. So the negative sign means that is the velocity in the downward direction. Okay, downward direction. So we have, that is only magnitude. Okay, so Vy is equal to 9.8 t. Okay, 9.8 t. So after time t, that is velocity 9. After time t, the vertical velocity is equal to horizontal velocity. So Vx equal to Vy. So what is Vx? That is 9.8. Okay, 9.8. 9.8 is equal to, what is Vy? That is 9.8 t. Okay, so therefore t is equal to 9.8 divided by 9.8, that is equal to 1 second. Okay, 1 second. So at a time t is equal to 1 second. So after the projection, at a time t is equal to 1 second, that is the velocity, horizontal velocity and vertical velocity becomes equal. Clear? So the next question, fifth question. Two tall buildings face each other and are at a distance of 190 meters from each other. With what velocity must a ball be thrown horizontally from a window of 55 meters above the ground in one building, so that it enters a window 10.9 meters above the ground in the second building? Very nice question. Okay. So let us visualize the situation first. That is two tall buildings. Okay, two. So this is the ground level. This is the ground. One tall building is here. Okay, one tall building. So this is the another tall building. Another tall building. So there is a window in the first building. So it is given, that is 55 meters above the ground. Okay, 55 meters. This window is 55 meters above the ground. 55 meter above the ground. So there is a window in the second building, that is 10.9 meter, okay, 10.9 meter from the ground. With what velocity must a ball be thrown horizontally from a window? So two tall buildings face each other and are at a distance of 190 meters. So this distance is given, that is 190 meter. Okay, 190 meter. So what velocity a ball be thrown? So this is the ball here. Okay, so one velocity it must be thrown like this. Okay, so that is the ux. So that it pass here. Okay. So that it enters a window 10.9 meter. So we have to find this velocity. Okay, velocity. With what velocity must a ball be thrown from the window of the first window, window of the first building? Okay, first building, so that it enters a window of. Okay, enters a window of, that is 10.9 meter above the ground in the second building. Okay, second building. So this is the point A and this is the point B. Okay, point B. So I am considering that is the vertical motion. Okay, vertical motion of the ball. Okay, vertical motion from A to B. Vertical motion from A to B. Okay, A to B. So I am using the kinematic equation again, that is S is equal to ut plus half at square. So rewriting this equation, that is Sy is equal to uyt plus half ay t square. Okay, t square. So what is Sy? Sy is equal to the next vertical distance travelled. Okay, so it is 55 meter. So 55 meter minus 10.9 meter. Okay, so 55.0, that is 10.9. Okay, 10.9. So 10, 1, that is 4, 5, that is 44 minus 44.1 meter. Okay, so uy is equal to 0, initial vertical velocity. Okay, 0. Ay is equal to minus 9.8. Okay, 9.8. So substitute the values. So what is the, we can find that is time of flight we can find. Okay, time of flight. That is the ball projected from this window and it enters the window of the second building. So how much time it will take? Okay, how much time it will take? So Sy, that is minus 44.1 is equal to uy, this term becomes 0, that's equal to half into ay, that is minus 9.8 into, that is t square. So this minus cancel. So 2, 4 times, that is 9 times. Okay, 9 times. So t square is equal to 44.1 divided by 4.9. Okay, 4.9. So that's equal to 441 divided by 49. Okay, 49. So 49 into 9 times. So 9 nines are 81, 1, 8. 36, 44. Okay, 44. So 9 times. Okay, 9 times. So therefore t square is equal to 9. So t is equal to 3 seconds. Okay, 3 seconds. This is the time of flight. So time of flight of the ball. So with this time, okay, it crosses how much horizontal distance? That is 180 meter. That is the distance between the first window and second window. What is the distance? That is 180 meter. So that is both for vertical motion and horizontal motion. That is time of flight is same only. Okay. So with this time t is equal to 3 seconds, it crosses the horizontal distance of 180 meter. 180 meter. So what is the relation? Velocity is equal to distance by time. Okay, time. So how much distance it passes? That is 180 divided by what is the time? That is 3. So from this we can find how much that is the velocity it projected. Okay, projected. So that is velocity means from this window the ball is projected with one velocity. So throughout the motion that velocity is constant. That is in the horizontal direction the velocity is constant. Very, very important. So from this velocity is constant. So the ball when it enters this window which has one horizontal velocity. That horizontal velocity and this velocity of projection is the same. Okay, projection is the same. So 180 divided by 3. Okay, 180 divided by 3. So 3, 6. So 6. Okay. So velocity is equal to so what? 60 meter per second. Okay, 60 meter per second. So that is asked. So that is so that with what velocity must a ball be thrown horizontally from a window of 55 meter above the ground in one building, so that it enters a window of 10.9 meter above the ground in the second building. Understand? So that is velocity. The velocity at which the ball is projected is 60 meter per second. 60 meter per second. Clear?